So the first thing we're looking at is solving, the main thing we're looking at today is solve the following equations. We're going to solve the following equations for the given variable. Now, for this whole test, if there's variables in both spots, we're going to get the bases to be the same. It is possible to solve these without getting the bases to be the same. We can use logarithms to solve it, but we haven't gone over that yet. So for most of those, if you see variables in both spots, we need to get the bases to be the same. That's just telling you what this type of problem is. So if we look at number 40, 2 to the 2x plus 15 is equal to 8 to the x minus 7. I need to get these two bases to be the same. 2 cannot be simplified any farther than it is. I cannot rewrite 2 as a number to a power, because 2 is prime as it's simplified as it gets. But what that tells us, and that gives us a hint that 8 most likely can be rewritten as 2 to a power. And if you're not sure what that is we can just go through and start trying different powers of 2 to get 8. And it does work out that 2 to the third power is 8. Questions on this so far? Because we needed the base to be the same. One of them's 2, it can't be simplified, so we just need to get 8 to be 2 to a power. Works out to be 2 to the third. Powers of powers multiply. 3 times x is 3x. 3 times 7 is 21. Since the bases, so we got the bases to both be 2. And the reason we're doing this is because if the bases are the same, the only way they can be equal is if their exponents are also equal. The only way that 2 to the 2x plus 15 is going to equal 2 to the 3x minus 12 is if 2x plus 15 is equal to 3x minus 12. 2x plus 15. Yep. 2x plus 15, yes, not minus. Now we just need to get x by itself. Since there is no x to a power, we don't have x squared. We can subtract 2x from both sides. 3x minus 2x is x, telling us that 15 is equal to x minus 21. Add 21 to both sides, telling us x is equal to 36. Questions on this here? Yep. Questions on the first one? We can go on and look at 41. Again, only problem is we have powers, variables in both exponents, so we need to get the bases to be the same. Now on the right-hand side, we do have 1/8. It is going to be nice to get the 8 out of that bottom of the fraction, so we can move it to the top. So we have 8 to the negative 1. Now at this point here, I need to see if 8 to a power can get us 512. It can, 8 to the third. Now, as we saw in the previous one, 8 is 2 to the third. We could reduce it further, but since 8, we can get both bases to be base 8. We don't have to take it all the way to base 2. Because the whole thing is if the bases are the same, not so much that we reduce it all the way down. we got them to be the same. Powers of powers multiply. 3 times 5x is 15x. 3 times negative 1 is negative 3. Here we're going to distribute the negative 1. Negative 1 times negative 4 is positive 4. Negative 1 times negative x is positive x. Since the bases are the same, the only way these two can be equal is if the denominators are equal, or if the bases are the same. The only way these two equations can be equal is if the exponents are equal. We don't have x squared, we don't have x to a power greater than 1, we just need to get x by itself. So we can subtract x from both sides, telling us that 14x minus 3 is equal to 4. X is not by itself, so we can add 3 to both sides, telling us 14x is equal to 7. Last but not least, we can divide both sides by 14, telling us x is 1/2. When x is an exponent, we can have positive, x can be positive, negative, 0. We can have any value of x we want. The only ones we have to be careful with is when we're solving for values inside of a log. What's inside the log cannot be 0 or negative. Questions on these first two here? We're ready to look at the next one. Okay. Questions on 42. Because 42 is going to be the exact same as the last two. We just don't have to do anything to it. The bases are both e. They're both the same. We would set the exponents equal to each other and solve. So really at this point, it's just 4x plus 7 is equal to 6x minus 35. Minus 4x, telling us 7x is equal to 2x minus 35. Add 35. Since the bases are the same, the exponents have to be the same as well, or have to be equal. So we set them equal to each other and solve. Let's look at 43. 43. 2e to the x minus 7 equals 5. There's no way to get the bases to be the same. Mainly because e is an irrational number. We don't have any other e's. There's no way for us to do that. So what we're going to do is solving with unlike bases. We need to get one term on either side. We need to get e to the x by itself equals a number. So for this here, first thing we can do to get e by itself is to add 7, because our negative 7 plus 7 is going to cancel, telling us that 2e to the x is equal to 12. E to the x, that base to a power is not by itself. So we can divide both sides by 2 to get e to the x, e to whatever that power is by itself. And that takes care of the first main step in solving here. Our second step is to get that variable out of the exponent, out of the power, or log. Here it's in the power, so we have to use logarithms. So for us here, we can apply the log that's going to simplify it. With e, we're going to apply the natural log. Because when we apply the natural log, our power property says we can move the exponent to the front, which does get it out of the log, giving us x times the natural log of e. So the natural log of e is 1, telling us that x is equal to the natural log of 6. And that's as far as we have to take it, because we got x by itself, we solve for x, and the value of x is the natural log of 6. We're done. You do not have to find the decimal approximation for the natural log of 6. That's as far as I want you to take it. Questions on this one here? Questions on 44? We good with 44? Or do we want to see that one? Okay. 44 is the exact same thing as 43. E, we have a base to a power. We can't get the bases equal. So we need to get our base to the exponent by itself. First thing we're going to do is subtract 9. Subtract 9 from both sides, telling us 6e to the 2x plus 1 is equal to 6. Then to get e, again, we still need it by itself. Next thing we're going to simplify is the 6. We need the 6 away from e, so we can divide both sides by 6, giving us this here. Questions on how we got e by itself? Now again, our second step is to get that variable out of the exponent or logarithm. And in this case here, to get it out of the exponent, we're going to apply a natural log. So we can apply the natural log to both sides. Well, the natural log of e is 1. And 1 times 2x plus 1 is just 2x plus 1. Natural log of 1 is natural log of e is 1. Natural log of 1 is 0. Log of 1 is also 0. So just solve for x. I mean, if you had on the test wrote the natural log of 1 minus 1 over 2, I would take that. I mean, that is the same thing. Questions on this here? (45) 7 to the x equals 3. Again, no way to rewrite 3 as 7 to a power or 7 as 3 to a power. They're both prime, we can't do it. But we do need to get one term on either side. Do we have one term on either side? The base to the exponent is by itself, 3 is by itself. So we can move this step 2 to get the variable out of the exponent. Now, since our base is not e, we're going to use log. Now, we can just use log and solve from here. But the nice one for this here would be log base what? 7. And there's a reason for that. Properties of logs will move the x to the front. Giving us x times log base 7 of 7 equals log base 7 of 3. As a reminder, log base b of b is 1. When the base and what's inside are the same, it's going to reduce to 1, which means our log base 7 of 7 is 1. Telling us on the left side we have x times 1, which is x is equal to log base 7 of 3. Since x is by itself, we're done. And I'm not making you guys find the value of that there. Just x is equal to log base 7 of 3. That's it. Questions on 45? We good with these two here? (11 to the 6x plus 2 equals 38. 7 to the 6x plus 2 equals 38. Do we have one term on either side? Yeah, we have the 11 to the power, 38 by itself. So we can move to step 2, applying log to both sides. And for us here, log base 11 is going to be nice. Because the goal of applying logs to both sides is to get this exponent, 6x plus 2, get that variable out of the exponent. And by applying a log to it, we're able to get the 6x plus 2 out of the exponent. So that's the one main thing we needed to do. The second is that because we use log base 11, our log base 11 of 11 reduces to 1. And 6x plus 2, when we multiply it, leaves us with 6x plus 2. Because 6x plus 2 times 1 is 6x plus 2. On the right-hand side, we still have log base 11 of 38. Questions on how we got to this here? Is x by itself? No. So we would need to first subtract 2, telling us 6x is equal to log base 11 of 38 minus 2. Then divide by the 6, telling us x is equal to log base 11 of 38 minus 2, divided by 6. Questions on this here? 47. Just like the first few we did today, first few problems we did today, this here is similar. If we have a log on either side and they're the same log, set equal to each other, the only way that two natural logs are equal to each other is if what's inside is also equal. The only way the natural log of 3x plus 2 is equal to the natural log of 4x minus 5 is if 3x plus 2 is equal to 4x minus 5. And for us to do this, we do need one log on either side. Is x to a power greater than 1? No, it's just x and x. Solve for x. Subtract 3x from both sides. These will cancel, telling us 2 is equal to x minus 5. plus 5. X is equal to 7. On any of the problems on the test, especially with equations, these equal signs, not the equality, equal signs. With logarithms, if you get more than one value for x, check them. None of these are no solutions. So a problem like this on the test, x is going to be 7. That is the answer. If we got 7 and -4, might want to check them. One of them's not going to work. There's a good chance one of them's not going to work. Questions on 47? '48 or 49, which one do y'all want to look at? Because they're the exact same thing. We feel good with those because, again, it's just setting them equal to each other and solving. Same with 50. Even though it's log base 2, we set here. So we say x squared minus x minus 6 is equal to negative x. We set, since they're both log base 2, the only way they can be equal is if what's inside of them is equal. Now, since we do have x squared, we're going to get this equation equal to 0. So we can add x to both sides. X squared minus 6 equals 0. Now, this is nice because we can solve this by the square root method. Square root method says if we have our x squared in the constant term, we don't have a term with x, we can get the x squared term by itself, then take the square root of both sides, because the square root of x squared is x, is equal to, we can leave it as the square root of 6, because the square root of 6 as a number is an irrational number. It's a non-repeating, non-terminating decimal. Now this here, we got how many solutions? 2. Might want to check it. So we have log base 2 of the square root of 6 squared minus the square root of 6 minus 6 is equal to log base 2 of negative square root of 6. Now on the right-hand side, negative square root of 6 is going to simplify to negative square root of 6, yes? What can we not have inside the log? A negative or 0. Is that a negative number? Yeah. This isn't going to work, because even on the other side, square root and square cancel, telling us that we have log base 2 of 6 minus the square root of 6 minus 6. It doesn't work. We cannot have the negative case. Even though both sides say the same thing, log base 6, or log base 2 of negative square root of 6 is not a number. There is no value for it. So the negative doesn't work, telling us that it is positive square root of 6. So that means any value of x that would make that negative or 0 is not going to work. So even 6 would not work, because the log base 2 of negative 6 doesn't work. Does that make sense? Okay. Because we could do the same thing with positive square root of 6, log base 2 of square root of 6, or negative square root of 6, sorry, not the positive. The negative is the one that works, because when we do the negative square root, negative square root of 6, on the right-hand side, the negative and negative make a positive. For some reason, I had in my head we were doing the negative case first. The negative square root of 6 Square root of 6 squared is going to make it positive, and the square root will cancel. It ends up being just the negative case. Okay. Let's look at these two here. So, questions, do we understand what happened here? Yeah. And it's the negative case because of negative x. So the positive case would be negative, so we throw it out. The negative makes a positive, so we keep it. 51, 52, we're looking at now logs. We're starting off with x inside the log. We need one term on both sides. So if we look at 51, the log is on one side, it's by itself. 2 is on the other. So our first main step is to get the variable out of the log. And we're going to put both sides to the base of what the log's base is. The log's base is 7, so we're going to put both sides to the base of 7. Yes, because log base 7 to the log base 7 is going to cancel, leaving us with what's inside, 4x plus 9. 7 squared, 7 to the second power, is that a nice number? 49. Questions on this so far? Solve for x. We're going to subtract 9, telling us 4x is equal to 40. Divide by 4, telling us x is 10. That's it. Questions on this here? Questions? Questions? Okay, head up. We good with 51. 52, what would the base that we're going to put both of these sides to? E. Because we can go straight to that because the natural log is on the left side, it's by itself. I know there's stuff inside it, but the natural log itself is by itself. So putting it to the base E will cause E to the ln to simplify, leaving us with 6x minus 2. Now e to the 7th, well, is going to be e to the 7th. E, no matter what the power is, unless it's the natural log, is not going to be a nice number. E to the 7th is not a nice number. Now at this point here, we just need to solve for x. So we can add 2, telling us 6x is equal to e to the 7th plus 2. And then lastly, we would, by 6, telling us x is equal to e to the 7th plus 2 divided by 6. And that's as far as you have to take it. Yes, there is a decimal approximation we could get from this. That's the answer. Because these problems here, I'm not asking you to approximate or find values or use the calculator to find the value. I'm asking you to solve. That is solved. Questions on 51 or 52? Do we feel good about 51, 52? Because 53 is the exact same thing. I'll let y'all have that one if you want to go back and make sure you understand it. You do have that one there. 54 is a little different. Is the log by itself there? No. We need one term on either side. So the first thing we need to do here is get log by itself. So we can add 4. Telling us the natural log of 6x is equal to 19. Now we have one term on either side. So we can use our base e to cancel out that natural log, telling us 6x is equal to e to the 19th. If e to the 7th was an irrational number, e to the 19th is still an irrational number. Divided by 6. Telling us x is equal to e to the 19th divided by 6. And even if it wasn't the natural log, anything above, say, 5, probably 4, as a base to the 19th is still going to be way too big. It's going to be a very big number. The only times we wouldn't is maybe 2, 3, but 1, but there's not 1. That would be that. $55. We have 2 logs on the same side, yes? If we have 2 logs being added, we can rewrite this as a single log with what's inside being multiplied. So we're just using our properties of logs, our product property. Now we can put both sides to the base of 5. These will cancel, telling us that x plus 4 times x plus 1 is equal to 5 squared, or 25. Now on the left-hand side, we can distribute this out. We've got to distribute to solve. X times x is x squared. X times 1 is x. 4 times x is 4x, and 4 times 1 is plus 4. Since we do have an x squared term and an x term, we do need to get this equation equal to 0. Now that we have the equation equal to 0, we can factor it or graph it. I'm going to go on and just graph it. Y is equal to x squared plus 5x minus 21. Plus 5x. X squared plus 5x minus 21. Yep. That's going to give us irrational numbers, it looks, or what is this? Yeah. Yeah, it's not factorable. Oh, 55, yeah. 55, it's not factorable. We'd have to use the quadratic formula. So this problem's not like this on the test. You would graph to find our 2x values and check. I'm going to stop here on this one, mainly because it's not going to show up on the test. We're not going to have to do that. And it's not so much I don't want to solve it. I don't want to waste the time solving it when we could do a different one. Yes. This one here will have a solution. I will also say none of the ones on the test or the bonus are going to require you to use the quadratic formula. This one's going to work. So again, just like 55, 2 logs being added together can be rewritten as a single log with what's inside being multiplied. We put both sides to the base of 2. To get the x out of the exponent. And 2 to the third is 8. On the left-hand side, we'll distribute our x, giving us x minus 2x equals 8. Since we do have an x squared and an x term, we do need to get this equation equal to 0. Now this one does factor, it is factorable. We can also graph it. -2x minus 8. We do cross at two nice spots. Second graph. We're again looking for what values of x make the y value be 0, which is -2 and 4. Now again, just like before, we do need to check both values to make sure we don't end up with a negative or 0 inside either one of the logs. Well, -2, even before we start simplifying, tells us that we have log base 2 of -2. Just based off that, it's not going to work. So that's out. We could also try it with 4. So the only correct answer for this one is 4. Again, so any value that would have made x be negative or 0, we'd have to throw it out. Questions on this here? All right. Inequalities are going to act the exact same way as equations. We just have to make sure that if we multiply or divide by a negative, we have to flip the sign. Now, I will tell you this, all the properties or problems like logarithms that have restrictions aren't going to show up on the test. None of the problems on the test will have restrictions. So I'm telling you that now so you don't even have to worry about it. Now, if we look at 57, again, we need one term on either side. We have the natural log by itself on one, 9 on the other. So we're going to put both sides to its base, and its base is e. So e to the ln. We'll cancel out, leaving us with x minus 1 is e to the 9th. Solve for x. X is greater than or equal to e to the 9th plus 1. Is x by itself? Here, for our natural logs, x would have to be greater than 1. E to the 9th plus 1 is greater than 1. So there are no restrictions anyways. (58) is the log by itself. Yeah. So we can, again, put both sides to its base, which would be 7. 7 to the log base 7 would simplify, leaving us with x plus 2 is less than 7 to the 4th is 24/1. Solve for x. We'd minus 2, telling us x is less than 2,399. Now this one does have restrictions because, again, what's inside the log has to be greater than 0. So x has to be greater than -2. Well, -2 is indeed less than 2,399, so we're just saying that -2 is less than x is less than 2,399. But none of the problems on the test are going to require you to put that restriction in or require you to find it. I've set it up so that none of those type of problems show up. Questions on 58? Questions on 59 or 60, one of those two that y'all want to look at? Or just any of the rest of them. saying so far we mainly dealt with log, so we can look at some of the exponential problems. So 62, 3 to the 4x minus 5. We need that 3 to the 4x minus 5 by itself, and it is. So to get the variable out of the exponent, we're going to apply log base 3 to both sides. Specifically, we need the log, but the base 3 makes this easier to solve. Now, log base 3 of 3 is what? 1. So that simplifies to 1, and 1 times 4x minus 5 is 4x minus 5. Now we need to solve for x. Add 5 to both sides, telling us 4x is greater than 100 log of base 3 of 108 plus 5. Lastly, we're going to divide by 4, telling us x is greater than log base 3 of 108 plus 5 over 4. So solving these inequalities really isn't a whole lot different than our equations. We just have inequality signs. Questions on this here? All right. The only thing we have left is the change of base. The change of base, which I think is at the very back. Yes? Okay. Write this at the bottom. So change of base, we're going to be, say, given log base 7 of 51. To do the change of base, we did? I don't think so. So either way, get a little more practice. Change of base, we want to rewrite it as natural logs and common logs. And log base b of m, base b of m is equal to log of m over log of b, which is also the same as the natural log of m over the natural log of b. Now for this here, first I want to rewrite it as log on top and bottom. Now for us here, what's m going to be? 51, and our b is? And we'll also write it as natural log. Well, m is still what? And b is, that is it. For rewriting it in terms of common logs and natural logs, that's all it's asking. Questions on that one there? A bigger eraser. Doesn't matter what it is. Log base 15 63rds of 9/16. There'll be 6 problems over change of base. That's all you have to do right there. Part 2, 6 of the problems are this. The other 14 of the 20 are solving. That's it for part 2. Questions on this here? All right.